One down, so that one is very easy. After 5, 6, 7, so what we have there is 0.7. Okay, so we're looking at likely question in 2025 WAEC. We have a setup here which is very similar to what we have in 2017. The only difference is that here we have the rheostat. Question number 3, electricity 2017. The only difference in that one, this is what we just figured out from that question and what we're asked to provide. Now the difference between this connection and what we had in 2017 is that in 2017 we had here a bulb connected across. Instead of the rheostat, they connected a bulb, but here we are using a rheostat in place of that bulb. That is just the difference. So every other thing applied. Now let's explain the various circuit symbols. Here A is ammeter, key here, this symbol is key or switch, and then this arrow is the standard resistor that will be connected. Here is battery, the longer side is the positive, the shorter one is the negative. If you have it 2 is battery. If it's only one like this, then it is a cell. So we have the battery here, and then the wire PQ is representing the potentiometer of uniform length 100. And this point we have jockey. This arrow symbolizes the jockey. This is what we call jockey. The job is just to make contacts. That's all. Or to hold wires. Then here is V, voltmeter. Voltmeter is never connected in series. If you look at this battery, standard resistor, the key, and ammeter, they are connected in series. That means the same current will go through them. If you come here, there will be a branch. Now, look at this also. The voltmeter, because it's a device of high resistance, it is never connected in series during experiments. If you do that, it's going to inhibit the flow of current. Therefore, for every apparatus, voltmeter is normally connected in parallel. Once you have ammeter, you have voltmeter, you connect voltmeter in parallel. That's what we have done. So, okay. This is rheostat, the symbol. And then every other thing that looks like line, straight line, whether it's curve or whatever, is the wire, the connecting wires. We are going to do the connection. If you look at my table here, you will see here, you have ammeter, the measuring instrument for current. It has black, it has the 2 reds. If you connect to this middle one, the highest current you can read here is between 0 and 1. If you connect to the third one, which is the second red, the highest current you can read here is between 0 to 3. You can see it, the up calibration is where you read if you connected at the center, and the down calibration is where you take if you connected at the second red. That is for that voltmeter. And then what I have here is what we call rheostat. It has a coil of wire. It's a variable resistor. It can be used to vary the current. Of course, when the resistance changes, current also changes, but the change is inverse, meaning that the higher the resistance, the smaller the current, and vice versa. We have other type of rheostat, like this one too, the bigger one, but they have the same strength, whether it's big or small, the same strength. But we're using this one. is connected already. We have wires connected. You connect one at the red here and then one at the black side, as the case may be. If you connected here, then you connect here. Since I connected here, then you connect to the black one. We are going to make use of two cells, which will give us a battery. Cell 1 and then cell 2. EMF 1.5, EMF 1.5. If you join the two, then you give you 3.0 or above that for fully charged one, between 3.0 and 3.2 volts for the battery we are going to use now. This is the key or switch. This is the key or switch. The one that is connected is this way. It has two terminals. It is not terminal sensitive, meaning that you don't have positive or negative. Anywhere you can connect. Unlike the ammeter that has terminal sensitive, the red is positive. Now we want to join the wires. If you look at the diagram, you will see that one wire from ammeter, you pick ammeter. There is one wire from potentiometer, you picked it. This potentiometer, one wire from it. I pick one wire from ammeter. So this one wire from potentiometer. This potentiometer, it has a uniform length of 100. Then this is ammeter. The wire here is negative. I'll pick it. Then I'll pick another wire from voltmeter. This is my voltmeter. I pick one wire from it. That's 4. Then finally I pick one wire from
Must it be black and black?
It must not.
Okay, must not.
Depending on it.
Okay.
Now the terminals. If you connect, whether it's black or whatever, once you connect and then the movement is backward, you change the terminal.
EMF, back EMF.
If it's going back, so 4 of them like this, we join them together. That's 4 junction. Then you go to our right, we have one wire from the rheostat, one wire from jockey, and one wire from voltmeter. Join together. The current produced from this battery is very small, so it cannot shock anybody. It has not even produced current enough for itself, let alone producing spark that can shock you. So you are touching the wire. Don't be afraid when you are touching the wire. It has these dry cells. One of the properties is that they have a high internal resistance. And what is internal resistance? It is opposition offered to current flow as a result of the chemical content of the cells between the poles. Now, the internal resistance of dry cells are very high, so the current produced are small, so it won't shock anybody. Free to touch the wires. Now, having done this, then you will complete the upper one. We have one wire from the key joined to ammeter, one wire from key joined to ammeter. That's what we have done now. One wire from key, the remaining side, joined to the ammeter, and then one wire from the remaining side of the key has been joined to the standard resistor. This is the standard resistor. Wire from here join here, and then the remaining part of the standard resistor has been joined to the battery as shown, joined to the battery. Now the connections are done. There's not wire that is free again. So if we had a compartment for our battery, the battery would have been closed permanently. But since we don't have compartment, okay, now I want to show the reading. Everything is connected. Then I can touch, use my jockey to make contact on the potentiometer wire. If you look at it, you will see that the ammeter is moving.
Release and put away.
You see the ammeter moving in the positive direction.
Releasing.
But voltmeter is going.
Release and put.
Voltmeter is going in a reverse way. Okay. So watch the movement of the ammeter. You see how it's moving. Now watch the movement of voltmeter. Now, because the voltmeter moved in a reverse direction, you change the terminal. What I will do is to remove the black, interchange their position. Interchange position. Interchange the position of the where we had the red will now take the place of black. That's what I'm doing now. And then the remaining wire. The remaining wire will go to the black. Okay, so let's check if everything is now working in the normal direction.
Yeah.
So you can see that the voltmeter is now moving in forward.
Yeah.
Okay, so the work of the rheostat here. Let's check what the rheostat will do. And the likely thing they will ask us here is to complete the circuit with the jockey, and then you move the rheostat and see where you have highest current. Maybe choose a particular point. For instance, I am putting it at 55. Now we want to take our readings. The first value we will take from here is put the jockey at the 10 cm mark, and then close. The battery is firmly corrected and connected, and then you place your jockey. Before then, close the key so that current can flow when you complete the circuit. Place the jockey at the 10 cm mark and then record your reading. From the current, I have, since we are looking for 3, before then let's show us how to read this instrument ammeter, you know we have 0, we have 0.6, we have 1.2. Now, how many lines do we have between 0 and 0.6? You count it. Stop there. Okay. So now, putting it at 10 cm, you count the number of lines here. I have 1, 2, 3, 4, 5. I have 5 lines there for ammeter. Let me cross check. 1, 2, 3, 4, 5. I have 5 lines. I go to the voltmeter. So that 5 lines, the reading is, because each line is 0.06, 0.06 times 5
is what? 0.06 times 5 is what? 3. How?
0.3.
0.3.
So we have 0.3 for ammeter. We'll now go to that of the voltmeter. We go to the voltmeter. The voltmeter, you are reading from the one down. So that one is very easy. After 5, 6, 7. So what we have there is 0.7. You record it. Record here 0.7 and then 0.3 as our ammeter. Now, if you look at the apparatus, of course, you know ammeter here is a device for measuring current. It has a low resistance, that's why it can measure current. Voltmeter does not measure current because it is a device with high resistance. It measures voltage. It's called voltmeter. Of course, the battery is the source of energy. And then we have the rheostat. The rheostat is a resistor, but the type of resistor is not a standard resistor. It's not fixed. The values are not fixed. It is one we call variable resistor. As you slide it here, as you slide this, you either go to the highest resistance or the smallest resistance. You detect it from the movement of the pointer and the ammeter. For instance, if you move, it's at the center now, place it at a particular point, let's say 40, and then you gradually move, the value is going down, so you keep moving the rheostat until you have, where you have the highest value, you stop the rheostat there. I think here is where we have the highest. We leave this rheostat in this position throughout the experiment so that we can be having steady current in the measurement and then the voltage. Okay, the key is just to open and close the circuits. When the key and the battery all close connected, you can see that no current voltage is flowing. The reason is that the jockey is still not connected across the potentiometer. So once you tap the jockey on the wire, then there can be movement. That shows you the circuit is now completed. So the function of the jockey is to complete the circuit. The aim of experiment here now, we know that resistance is directly proportional to the length. Now, as you increase, and this resistance, which means the higher the resistance, the higher the length. The higher the length, the higher the resistance. And if the resistance is higher, current will be lower. So, we're trying to find the resistance of the wire across this section. as you are moving your jockey from the least length like 10, you are advancing towards 20, 30, 40, 50, 60 to 100. The value of current will keep dropping. That is the aim of this experiment. Potentiometer itself is used to compare resistances or EMF, and it's very accurate in the comparison. If you take for instance voltmeter to measure EMF, voltmeter has its own resistance, so it will affect, and it has pointer, it will affect the value. But potentiometer itself does not have moving parts, it does not have pointer, so it gives more accurate comparison for cells and resistances. But in this experiment, it's measuring the resistance.